All right, Mr. Ahmed here for 7.3. Goal for today is to multiply some special products of polynomials, and these are going to really involve binomials. And we're just going to start with a warm-up here to kind of lead us to where we're headed. So the first question says, what is another way to write x plus 3 times x plus 3? Keep in mind these parentheses group those two values together. So really this means we're multiplying something by itself. Anything multiplied by itself, something like x times x, multiplied by itself, that's equal to x to the second. So in a similar manner, x plus 3 times x plus 3 is also equal to x plus 3 squared. So when we were working on our exponents last unit, we talked about when we see parentheses and the exponent outside, we distribute it to everything inside. Now everything inside was being multiplied. In this case, these are separated by a plus sign, so these are two different terms. I can't call this x squared plus 3 squared. I can't distribute an exponent over a plus sign. It needs to, everything inside those needs to be multiplied in order for us to use that property. So, utilizing what we know about multiplying and FOILing, we have to multiply x plus 5 squared. Now, the common error is someone's going to call this x squared plus 25. That is not correct. I have to rewrite this problem as x plus 5 times itself x plus 5. Then from there I FOIL. Distribute the x, distribute the 5. And we will find out we don't just get x squared plus 25. There's going to be a middle term. So x times x is x squared. X times 5 is plus 5x. Now when we distribute the 5, we get another 5x. And 5 times 5 is 25. So x squared plus 25 is close, but we still have these two, so that adds up to 10x. So we can't just call this x squared plus 25. It's x squared plus 10x plus 25. Okay? So that's with a plus sign. Now, here we're going to square with a minus sign in between it. So again, I can't just call that x squared minus 9. I probably would make an error on that too. So rewrite it, x minus 3y times itself, x minus 3y. Now we'll distribute the x. X times x is x squared. X times negative 3y is negative 3xy. We have both an x and a y. Here we have a negative 3xy. Could also call it yx, but I kept it in the same order. And then a negative times a negative is a positive 3 times 3 is 9y squared. Okay? Now our middle term can get combined. Those are like terms. So I have x squared minus 6xy plus 9y squared. So this leads us to our two special cases when we square a binomial. When we square a binomial, we can look at the two terms inside, and we will always know that it's going to equal the first term squared plus, if there's a plus sign, 2 times the first term times the second term. So that's 2ab. And then the last term squared. When it's a minus sign, the only thing that changes is the middle term is negative. So for us to do this, using the shortcut, I could look at this and square the first term, which is x squared, plus, because it's a plus sign. Now I have to take 2 times these 2. So 2 times x is 2x, and 2x times 8 is 16x. So I take 8 times x times 2. So I get 16x. And then we'd square the last term. 8 squared is 64. Now if you do not like that method, that's okay. You can just rewrite it x plus 8 times x plus 8, and you can FOIL it out. You'll still get the same answer. Let's take a look. X times x is x squared. X times 8 is plus 8x. That's a 16, so we need another 8x. When we distribute the 8, plus 8x. Now that's going to add up to our 16, and 8 times 8 is 64. So realistically, you can use either method. I don't care. Probably foolproof to rewrite it, but if you got it figured out, you are good to go. So the reason why I say foolproof too is, keep in mind, 2x squared is not 2x squared. 2x squared is 4x squared. We have to multiply 2x times 2x. So that would be 4x squared. Now I can multiply these two together. It's going to be a minus sign because it's a minus. 2 times 5 is negative 10x. Times 2 is 20x. Then 5 squared is plus 25. So, like I said, you could rewrite it and FOIL it out. Choice is yours. All right, sum and difference pattern. In this case, if we see two binomials with a plus b, so the first terms are the same, one's a plus, one's a minus, and the last terms are the same, we're always going to get a squared minus b squared. So if I were to FOIL this out, the way it's going to look, I'm seeing the special case. I have an x, I got an x, I got a 10, I got a 10. One's plus, one minus. So I should just get x squared minus 10 squared, which is x squared minus 100. Now, seeing how that works, you could always FOIL it too. X times x is x squared minus 10x plus 10x. These cancel each other out. Positive 10, negative 10, gone. 10 times negative 10 is negative 100, and we got it right. Okay? So again, same pattern, 2x plus y minus y. So I can square the first term. Keep in mind, 2x squared is not 2x squared. 2x squared is 4x squared. Minus the last term squared, which is y squared. We got it. A couple U tries, hit pause, and we'll check our answers. All right, hopefully you had some success. So I'm going to use the shortcut. If you want, you could rewrite it and FOIL it. I don't care. I see that's a difference, so I have x squared. Multiply these together, that's negative 9x. Double it, and I get negative 18x. 9 times x times 2. Plus 9 squared is 81. All right, 4x squared. 4 times 4 is 16, so that's 16x squared. Now I have to take 3 times 4. Oh, this is a minus, this is a plus. Okay, I almost got the wrong one. This is the sum and difference. So 16x squared, we're good there. Minus 3 squared is 9. Or you could FOIL it and check your work. So in summary, a couple things here. You can always use the FOIL method to check your work, or you can use the shortcuts. The choice is yours. Have a good one.